All right. Selecting which 7 players will be in the batting order on an 8-person team. Now, you have to ask yourself permutation or combination or multiplication counting principle, okay? So here's the thing, though. This one tried to trick you because it actually says the word order, but they're not talking about the order of the players. They're talking about selecting which of the 7 players are going to be in the order.
But order matters in this.
It does, but they're not talking about the order of the baseball team and how they're batting. They're just saying...
There should be 9 players.
Well, one's sick. It's Little League or something. But do you see what I'm talking about? This is not an order problem.
Oh,
this is selecting 7 out of the 8 players, so this would be 8C7. I know.
So
yes. The whole thing. Yep, the whole quiz you get your calculator for. And so when you do that, get your calculator out, and you'll go 8C7. And there would be 8. So there's 8 possibilities, which makes sense. You know, someone gets left out. One person will get left out. That sucks. Okay, number 2. There are 15 applicants for up to 2 job positions. They will pick at least 1. Now, there's 2 scenarios going on here. They're either going to pick 2 people, okay, and that would be a way, or they're going to pick 1 person for the job. Okay, so you need to take those 2 possibilities and add them together. So it doesn't matter what order this is in. The 2 jobs are the same position. So out of the 15, they're going to choose 2 people. Or, I'm not multiplying these together because this is not the same situation. These are different situations. Or out of the 15, they're going to choose 1. Now, if I didn't say they will pick at least 1, we would have then added 15 choose 0.
Didn't say the job positions are the same or different. Just says
2 job positions. So you would have to just assume that they're the same, because if they were different, they would have said they were different. Yeah. Okay, so then you get 15 choose 2 plus 15 choose 1. That's what? 105 plus 15? 120. 120 different possibilities of choosing 2 or 1 person for the job. Maybe 50, out of the 15, there's only 1 good person. Okay? All right, so both of those were combinations. Both of those were C, here, and here. Now with permutations, you can use permutations or you can use the multiplication counting principle. So if you said it was the multiplication counting principle, someone else said permutations, you're actually both right. So let's take a look. A team of 12 dodgeball players needs to choose a captain. Now the captain is better than the co-captain here. Okay? So like the president and the vice president. And so this would be permutation or combination? Permutation. Out of the 12 dodgeball players, you're going to select 2 of them, but order matters here. Okay? The other way to look at it is to use the multiplication counting principle. I have 12 people that are qualified to be the captain. After I've chosen the captain, now there are 11 people that I could choose to be the co-captain. And both of these will give you the exact same answer. Okay? So you can say permutation or you can say multiplication counting principle. Either way, you get 132. So order mattered here because the positions were different. And I know co-captain sounds like they're the same. Captain and a co-captain, like co-champs. But they're different, yeah. Okay, number 4. A group of 20 people are going to run a race. Ooh, Cammie, you're running a race tomorrow. Oh, poor Cammie. She got so mad. I know.
Did you see that video?
Poor girl. Okay. All right, we're going to run a race, and the top 3 runners earn gold, silver, or bronze. Very different, okay? So this would be, out of the 20, we need 20 permutations of 3. Okay, the other way to look at it, of course, is to have 20 people can come in first, then 19 people would then come in second place. For bronze would be 18. Either way, you're going to get, 6,840 different possibilities. That's a lot. Yeah?
Is it always true that if there's a permutation that you can use the counting principle?
Yes. I talked to Miss Cowie about that this morning. Yeah, we were talking about how you could do that. But if you had 50 people and you needed to find the first 30 in a row, you wouldn't want to use multiplication counting principle. You'd want to use,
The counting
permutations.
principle never works with
It doesn't.
Combination.
No, because the counting principle doesn't work with combinations, because if, I always do this as Alice, Bob, and Carol, right? Yeah. And if you switched Bob, Alice, and Carol, well, that's the same group of people still. Yeah. Okay, here we go. A math quiz has 5 multiple choice questions. The answer is either A, B, C, or D. Okay, so this one I would use multiplication counting principle, because I don't have, there's no order here. I'm not choosing a group of something. So I have 1, 2, 3, 4, 5 different questions on my test. And how many options do I have? 4. So I have 4 choices here times 4, because this is all one test. I'm not adding up all my different possibilities. This is one Scantron that's going to have all 5. And so this would be 4 to the 5th, which is, go to your calculator, 1,024. Isn't that crazy to think about that? It's only 5 questions,
Imagine guessing.
right? Yeah, that's not good odds to guess. Go in and just guess. That's why I like SAT. All right, arrange 5 books from left to right. So I have 5 books. I don't know if I own 5 books, but 1, 2, 3, 4, 5. And I'm going to choose 1 to line up first. Or you think of children lining up. How many different ways? Well, I have 5 books to choose from, and I put 1 on the shelf. And I look at my stack of books, and now I have 4 books to choose from. And then I have 3, 2, 1. So this is a factorial problem, 5 factorial, which is 120. Okay. All right, so that was all 9-1 stuff. I think 9-1 is going to be the hardest part of the quiz. Yeah. Just deciding which one, you know, is it permutation, is it combination, you know, and am I trying to trick you? Yes?
Yeah, you always are.
No, it's not true. Yeah, Sydney.
How do you know it's a factorial when it's not?
Well, this one, because it was all 5 books and I wasn't just choosing a few of them, it's factorials all the way down to 1. Mm-hmm.
So I have like 2 questions. For number 5, you said that you would rather use the multiplication counting principle.
Yes.
You said you could still use.
No, you can't use permutations for that. You have to use multiplication, yeah.
And my second question was that, like, for number 1.
For the binomial theorem, you can do Pascal's triangle, or you can do on your calculator. What do you prefer? Do you prefer calculator? Okay, so you're going to go to your calculator, and you're going to put in 3C bracket 0, 1, 2, 3. Close the bracket. And when you do that in your calculator, it will give you 1, 3, 3, 1. Okay, I know the third row. The third row is always 1, 3, 3, 1. Okay, so now let's take that, and we're going to expand it. So write those numbers down. 1, 3, 3, 1. Give yourself some room. Okay, and now we're going to take the first term here, which is 3x, and we're going to cube it. And that 3x is going to get lower and lower and lower in its exponents until it's not even there. And then we have 3x squared and 3x, okay? And then 1 is, we're going to skip the first one. 1 is going to be to the first power, and 1's going up squared, and then 1 cubed. Okay, yes. But if it was something else, then yeah. So I'm doing it just like normal. And then if it's minus in the middle, then the first term is positive, negative, positive, negative. And now we need to simplify everything. Okay? Don't make this mistake. A lot of people like to do 3x cubed, but don't forget you're cubing the 3 also. 27x cubed. Okay? Think about if you were going to FOIL out 3x minus 1 times 3x minus 1 times 3x minus 1. Your first term would be 27x cubed. And then minus 27x squared here, plus 9x minus 1. Okay? Yeah, this was a hard lesson for some, but once you get the hang of it, I think it's not too bad. Easy lesson? Yeah. Slight work? Okay. Part B. Now we're going to have powers raised to powers. And what do you do to the exponents when you have a power raised to a power? You multiply. Yep. Okay. So we have to go to the 5th row of Pascal's triangle, or, you know, so it's going to be 1, 5, 10, 10, 5, 1. I don't think I gave myself enough room. We'll see. Okay, So the y to the fourth is now the first term. So the y to the fourth is going to be raised to the fifth power. If you want to do that in one step, go ahead. I like to write it out and then fix everything. And then I have y to the fourth is raised to the fourth power. And then y to the fourth is cubed. And then we're going to square it. Did you give yourself enough room? I didn't. And then we're going to go y to the fourth to the first power. All right, and then x will be, skip that one, x to the first, x squared, x cubed, x to the fourth, and then x to the fifth. And it's going to be pluses in the middle of all of this. This isn't easy on an iPad. There we go. Okay, how does yours look? Nicer than mine? Probably. All right, so now we get y to the 20th power, y to the 20th, plus 5y to the 16x, plus 10y to the 12th x squared, plus 10x to the 8th, I'm sorry, whoopsies, y to the 8th x cubed, plus 5y to the 4th x to the 4th, bless you, and then finally plus x to the 5th. Woo! How good was that?
That was long.
I know. How would you like to FOIL all that out, though? I would mess up so bad. There's no way I'd get that answer. I wouldn't. There's no way. Would you? If you had to FOIL that whole thing out? Mm-mm.
Yeah.
Not a chance.
Yeah, make an extra credit.
No, that's a waste of time. Okay, here we go. Now we're going to just find one term only. I like these. Do you want to try this one? Do you remember how to do it? Yeah? Okay, so these are the ones that we talked about. So this is going to be 7C, C4, yum, 7C4, and then the 2x, the whole thing, all of the 2x term, this first term is cubed, and negative 4y is to the fourth power. Okay, so remember some things. This 4 will match up with this, and then together the 3 plus the 4 adds up to 7. Okay. All right, so then you do 7C4 on your calculator. 7C4 times 2 cubed times negative 4 to the fourth. And that will give you, did you get it? 71,680. X cubed y to the fourth. You don't need the x cubed y to the fourth. They're just asking you for the a value, so you could just write that down. You getting the hang of those a little bit better too? Okay, let's look at this one now. This one's a little trickier because there's no y. It's -3 instead of a variable. But it's still the same idea. 6c, and if you want to skip that part that you do, if you're not sure what that number is, and you do x is to the fourth, -3 would have to be to the second. Yeah, it'd have to be squared. Because they're going to add up to 6, which makes that number there too. Because x is to the fourth, this would have to be squared because these always add up to 6. Unless there's an x to the power inside of there. Because remember on this last one, these did not add up to 5 because there was an extra power in there.
I mean, like, for 6, choose 2, I do 2.
Because it's always on the second one.
Oh.
Okay, so 6 choose 2 times -3, you should get 135. Yep. Good? Okay. Over. What time are we up? We're on extended. 9:50. All right. Can we do this in 10 minutes? We'll see. Now, given the sequence, I do give you the explicit formulas, okay? So explicit for arithmetic, if you want to write this right above your page, it's a sub n equals a sub 0 plus dn. I also give you the other one too, if you like it. I don't use the other one, but some of you might. And then geometric, I use a sub 1 times r to the n minus 1. Okay? Just so happens that they're both number 9 here. Whoopsie, typos. This is going to go with this one, and this is going to go with that one. Okay, here we go. Let's do number 9, the first number 9. So, given the sequence, -4, -8, -16, -32, we need to find a recursive formula. First of all, you need to find out what type of sequence this is. What's happening each time here? We're multiplying by 2. Perfect. There is a constant ratio of 2. And so to write the recursive formula, remember you have to tell me what the first term is, tell me where to start, and then you're going to tell me to take the previous term and just multiply it by 2. You can put that 2 on the front, put it on the back, doesn't matter. 2 times a sub n minus 1. All right, explicit formula would be to find the nth term of the formula explicitly. You would go to -4 is your first term. You're multiplying by 2 to the n minus 1. Okay? If you like the other one better, you can use that one too. So the other answer would be -2 times 2 to the n. That's the other answer. Okay, and then find the 9th term. You would just plug in 9. So a sub 9 equals -4 times 2 to the 8th power. And then you go to your calculator and you get, anyone do it? -1024?
Yeah.
Perfect. -1024. Okay? Yeah, I think this is probably the easiest lesson out of all of them because this is old stuff. But maybe you didn't like this last year and you don't like it this year. All right, the second number 9, we need to find a recursive formula, but we need to find out what's happening each time here. When you see something like this, you think, oh, it's multiplying by 2. It's not. Sometimes if you can't figure out a pattern, rewrite it. This is 2. This is 2.5. This is 3. This is 3.5. Do you see what's happening each time? Yeah, you're just adding 1/2. You're adding 0.5. Okay, if you want to write it as decimals, you can. So recursive formula would be to tell me the first term, it's 2, and then each term after that is to take the previous term and add 1/2 or 0.5, whatever you like, decimals or fractions. Okay. All right, an explicit formula, I would do a sub n equals, I like the a sub 0 one a little bit better. If you don't like that one, that's okay. So a sub 0 would be 1.5. So I'd subtract 0.5 to go the other way. And then I'm adding 0.5 n. Okay, so that's an explicit formula. And then to find the 30th term, you're going to plug in 30. So the 30th term is equal to 1.5 plus 0.5 times 30. So that would be 15 plus 1.5 is 16.5. There you go. Or 32 over 2, if you want to write it as a fraction. So far, so good? All right, number 10. This one, my other class is like, you could just look at it and find out the answers. And I'm like, yeah, that's kind of true. But let's say we didn't look at it and find the answer. So you see it? We have the 11th term. And then we have the 37th term. And I want to find the common difference here because it's arithmetic. And so if I were going to take 110, I would need to add D how many times to go from 11 to 37? 26 times? And that would equal 370. Okay? You take 110, the 11th term, add D 26 times to get 370. So we're going to subtract 110. 26D equals 260. So D equals 10. Common difference is 10. And now I need to write this in my explicit formula. So if I am at the 11th term, which is 110, I would then subtract D, which is 10, how many times to get to the a sub 0 term? 11. Does that make sense? You're at the 11th term. You want to subtract D because we're going backwards now To get to the 0 term, you do that 11 times. And guess what you get? You get 0. So my formula is a sub n equals 10 times n. A sub 0 is 0 plus 10d would be just 10n. And a lot of people in my last class were like, you can just look at it and you can see it, huh? Yeah, the 11th term times 10, the 37th term times 10. Okay, the next one's a little trickier. The 3rd and 5th term are 25 and 6.25. So here's the 3rd term, 25. And then we have a 4th term. And then the 5th term is 6.25. And so to get from the 3rd term to the 5th term for geometric, I'm going to multiply by r how many times? 2. And you've noticed it's just the difference, right? 5 minus 3. Up here, 37 minus 11. It's just the difference. So r squared would equal 6.25. Now, divide by 25. R squared equals 1/4, or 0.25, if you did it on your calculator. Take the plus and minus square root, and there's actually 2 answers to this. Okay? Because it's geometric, you could have, you know, in between, it could go positive, negative, positive, negative. So negative 1/2 would also be okay. All right, so now we need to write this in an explicit formula. So we need to find our first term. So we're just going to go back a few. The second term would be what? 50. And then the first term would be 100. Okay, so a sub n equals 100. And I'm just going to write plus or minus 1/2 to the n minus 1. And that includes both of them. You could separate it into 2 different formulas. But anytime you're taking an even root of both sides of an equation, it's plus or minus. So if that's r to the 4th, r to the 6th, if it's r cubed, there's only one answer. Okay? All right, and then finally, number 12, converges or diverges, and if it converges, give the limit. Let's do B first, because B is easy. B is a formula. When you have a formula, it's easy just to look at that through binoculars if you want to. That's weird. And I usually just take n over n squared. Look at that. N over n squared, which reduces to 1 over n. And as n goes out to infinity, I'm taking the limit, if you will, then you get 1 over infinity, so this is going to converge to what? 0. And if you remember your asymptotes, it's the same thing. This right here would be a graph, and as you go out to infinity on x, then the y's get closer to the asymptote, which is y equals 0. Okay, it's about the degrees. The degree on the bottom is bigger than the degree on the numerator. Now this one over here is a little tricky to see. You could, if you wanted to, go to your calculator and start evaluating these things. 1.5, this is 1 point something, and you get 1.8, 1.83, but you can't really tell what it's actually going to until you have a formula for it. But we can write a formula for this, okay? Think about just the top as its own sequence and the bottom as its own sequence, right? The top is adding 2 each time, right? So what kind of sequence is that? Arithmetic. And if we wanted to write an arithmetic sequence for this, we would do a sub 0, which would be what? 1 plus 2n. Do you agree with that? Just the top. A sub 0 would be 1, because you would subtract 2, and then it's adding 2 each time plus 2n. Now what's the bottom going to be? Yeah, exactly. And you can maybe even see that is just n plus 1 or 1 plus n. This is also arithmetic. It's just adding 1 each time. If I went back, it would be 1 plus 1n. And now I can think of it like that other one over there. And I look at 2n over n, and that's going to converge to what? 2. Converges to 2. Okay? So you got to look for a pattern on the top and bottom. Sometimes it's arithmetic, sometimes it could be geometric, and then get a pattern.